Hello, in this video we'll try to learn the Descartes rule of sine. So before I write down the Descartes rule, so let us see what we have learned in our previous video. Okay, if you remember in our previous video what we were given a function of x which is 2x cubed plus 5x squared minus 4x minus 3. Now what we were asked to find all rational zeros, and we found all the rational zeros here, and then we were asked to find what all the x-intercept or the real zeros of that function. Now after we found all the rational zeros, then what we have to test one by one. We have to test +1, we have to test -1, we have to test +3, we have to test -3. So we tested basically many things before so our objective is what? To arrive the remainder is 0. Once we have the 0, then we get one real zeros. Now so we need to test a lot. Okay, so Mr. Descartes' rule of sine is going to tell us which one we should test first, and how many real zeros are going to be positive, how many real zeros are going to be negative. All right, so let's see. So what is given? Let's say I have I have a function of x. So this is I have a function, polynomial function of x. Now I want to find the number of positive zeros. Okay, so number of positive zero. Number of positive zero is going to be equal to number of variation of sine in function of x or less than even integer. All right, so now let's see the other theorem, which is a number of negative zeros. Okay, so how many number of negative zeros? So number of negative real zero in a function is going to be number of variation of sine in this time function of negative x. Okay, not function of x, or less than an even integer. Okay, so let's so this is the theory. Okay, so let us look at an example. All right, so let's say I have a polynomial function of x equals x power 5 minus 3x cubed minus 5x squared plus 9x minus 7. So this is my polynomial function. Okay, so we need to find the variation of sine in function of x. Okay, so let's see how many sine variation I have in my function of x. So this is positive, and next term is what? Negative. So this is what? One variation. Okay, now this term is negative, this term is negative, so it's not a variation, so there is no variation. Now this term is negative, this term is positive, so I have another sign variation. This term is positive, this term is negative, so I have another sign variation. So how many sign variation in total I have in function of x? 3 sign variation. Okay, so this is basically what? 3 sign variation. So how many what is going to be my number of so number of positive real zeros are going to be what? 3. Okay, or what? 3 minus an even integer. So what is 3 minus an even integer? 2. So it is going to be equal to 1. Okay, so the possible number of positive real zero is what? 3 or 1. Okay, now let's look at the negative real zero. Okay, so for negative real zero, I need to find what? The sign variation in function of negative x. So let's first find out function of negative x. What is function of negative x? X power 5. So it is going to be negative x power 5 minus 3 x power x cube. So negative x cube, and then negative 5 square. So negative 5 negative x square, and then plus 9. Instead of x, I'm going to write negative x minus 7. So if I do that, I got negative x power 5 positive 3x cube minus 5x square minus 9x minus 7. Right, now let's see how many sign variation I have. Okay, so obviously I have 1 here, and then what? Then this is a positive one, this is a negative term, so I have another sign variation here. Let's see, this is a negative term, this is a negative term, so no sign variation. This is a negative, this is a negative, so no sign variation. So how many sign variation I have? I have 2 sign variation in function of negative x. Okay, so what is going to be my number of negative real zeros? So number of negative real zeros are going to be variation in function of negative x, which is 2 or 2 minus an even integer. An even integer is 2, so it is going to be equal to 1. So what is going? It is going to be 2. So 2 or 0. Oh, sorry, this is going to be 0. 2 minus 2 is 0. So 2 or 0. So in a nutshell, I can have what? So now my number of positive real zero is what? 3 or 1. Or number of negative zero will be what? 2 or 0. Okay, so that is basically the Descartes rule of sign. All right, so now what I am going to do is I am going to basically solve a large problem where we are going to try to find real zeros of a polynomial function. Okay, so let's solve a problem. All right, so let us see. So we want to find all the real zeros of this polynomial function. So I have a function of x which is 3x cube minus 8x square minus 8x plus 8. All right, so find all the real zeros. Find all the real zeros. Okay, all the real zeros or x-intercept. So that is our problem. Right, so before I try to do anything, first of all let's see. So this is what? The highest power is x cube. So this is an third degree polynomial. So here n is what? Equal to 3. Okay, so that means what is the maximum number of real zeros I can get? So maximum number of 0 is what? Equal to n, which is 3 in this case. So I can have at a maximum 3 real zeros. Okay, so that's fine. Now let's apply the Descartes rule of sign. So for the Descartes rule of sign, the positive real zeros, so number of positive zero is going to be dependent on what? Number of sign variation. So let us see number of sign variation in function of x. So this is positive, this is negative, so I have one sign variation here. This is negative, this is negative, so no sign variation. Now this term is negative, this term is positive, so I have another sign variation. So in total I have two sign variations. So I can have as a two positive real zeros, 2 or what, 2 minus 2, so which is equals 2 or 0. Now let us see the number of negative real zeros. So for number of negative real zeros, I need to find what? Function of negative x. So let's find out function of negative x. So if I want to try to find out function of negative x, what you do, flip the sign of odd power. Okay, so this is cube, so this sign is positive, so make it negative, so negative 3x cube. Do not change the sign of even power term, so keep it negative x square. So this is x power 1, so this is odd, so I'm going to change negative to positive, so it is going to be positive 8x, and do not change the sign for the constant, which is positive 8. So now let us see how many sign variation I have. I have only one sign variation. All right, so what is going to be my number of negative real zeros? So number of negative 0 is going to be what? 1. All right, so let's review a little bit, shall we? So first of all, we found that that I can have a maximum 3 real zeros, as this is a third degree polynomial, and out of that 3 I can have 2 positive real zero and I can have 1 negative 0. All right, so please keep that information in your mind, right? So now I am going to basically try to find all possible rational zeros. So let's write down all possible rational zero, which is what? Equals p over q. What is p? It is a factor of positive 8, so factors of 8 over factor of 3. Okay, over factor of 3, factors of 3. So let's write it down. So factor of 3, of course we know it is plus minus 1 and plus minus 3, no problem. What are the factor of 8? Which is going to be plus minus 1, plus minus 2, plus minus 4, plus minus 8. So these are my factor of 8. So let's do one by one. So first I'm going to use plus minus 1 as a denominator. So plus minus this plus minus 1 over plus minus 1 is plus minus 1, and then plus minus 2 over plus minus 1 is plus minus 2, plus minus 4, and plus minus 8. Okay, and then I'm going to use this plus minus 3. So plus minus 1 over plus minus 3 is what? Plus minus 1 over 3, plus minus 2 over 3, and then plus minus 4 over plus minus 3 is what? Plus minus 4 over 3, and finally plus minus 8 over plus minus 3, which is plus minus 8 over 3. So these are my all possible rational zeros. Okay, now as you can see, I have plenty of positive real zeros and plenty of negative real zeros, and you know that I can have 2 positive real zeros and 1 negative real zero. So which one I'm going to test first? I'm going to test actually the positive real zeros first. Okay, so let's do one by one. Okay, so first of all, let's see. So what are my objective? My objective is to find basically the remainder. What is the remainder theorem? R equal to function of a, and we will try to see if it is equal to 0 or not. Once we have 0, we are going to find. So let's find start function of, and I'm going to use positive number. So here positive 1, function of positive 1, and I'm going to try to find what? Function of positive 2, because that's the second one, positive 2. Then what? Function of positive 4, and then function of positive 8, and then function of positive 1/3, and then function of positive 2/3. So let's try to find one by one. So function of 1. So what is my function of x? 3x cubed. So it is 3x is 1 cube minus 8x square. So 8 1 square minus 8x. So 8 1 plus 8. And you are going to find it is not 0. Okay, so this is not 0. If you punch the calculator. What is function of 2? It is 3 2 square minus 8 2 square. Well, it is going to be, the first one is going to be 3 2 cube. 2 square minus 8 multiplied by 2 plus 8. This is also not 0. Function of 4, 3 4 cube minus 8 4 square minus 8 multiplied by 4 plus 8. If you punch the calculator, you are going to find this is also not 0. Okay, so and you are going to find function of 8 is also not 0, and you are going to find function of 1/3 is not going to 0. What about function of 2/3? So it is 3 2/3 cube minus 8 multiplied by 2/3 square minus 8 multiplied by 2/3 plus 8. And if you punch the calculator, you're going to find this is going to be equal to 0. So that means finally what I found that x equal to 2/3 is a real 0, is a 0 or x-intercept. All right, so this is a real 0 x-intercept, or I can say what? I can say x minus 2/3 is a factor. So I found at least one real 0, which is x equal to 2/3. All right, so to find the other real zeros, I actually need to do the synthetic division. So before I do the synthetic division, let me write down the original function again. So we need to do what? Synthetic division. Synthetic division. So what is my function of x? My function of x, if I want to rewrite, 3x cube minus 8x square minus 8x plus 8. Okay, so this is my original function. So so if I want to do the synthetic division, first of all I need to write all the term in descending order, which is already there: x cube, x square, x, and then the constant term, and I do not have any missing term. So that means I can now write down the coefficient. So it is 3, -8, again -8, and then +8, and in this box I'm going to write what? 2/3. So it is going to be 2/3, and I am going to draw the horizontal line. So I already set up my problem. So let's now do the first one. Okay, so I'm going to take down that 3 downward, so which is 3 here, and then I'm going to multiply 3 by this 2/3. So 3 multiplied by 2/3 is actually positive 2. And now, so -8 +2 is what? -6. And now I want to multiply -6 multiplied by 2/3, which is going to be equal to -4. Now -8 and -4 become -12. Then let's multiply -12 by 2/3, which is become -8. And -8 and +8 become 0. So my, of course, remainder is 0. And let's see the quotient. Okay, so highest power of my original polynomial is x cube, so highest power of my quotient is going to be x square, and that coefficient is 3, and then the next coefficient is -6x, and -12 is going to be my quotient. Alright, so let's rewrite my function. Function is what? My quotient, which is 3x square minus 6x minus 12 multiplied by my this factor, which is what? X minus 2/3. Okay, now as I want to find all the real zeros of this function or x-intercept, so function of x need to be equal to 0. So I'm equating function of x equal to 0. So if I do that, I need to write what? X minus 2/3 equal to 0, or 3x square minus 6x minus 12 is equal to 0. So from here I got x equal to 2/3. So this is my one x-intercept or 0, which we found before. And then for the other one, we can do quadratic formula or factoring. So let's do the quadratic formula. So if I do the quadratic formula, what is my x? X is going to be minus b. What is my b here? -6 plus minus square root b square. So -6 square minus 4a is 3, and c is -12 over 2a. 2a is 3. So if you basically simplify, you are going to find the values are basically equal to, so it is going to be actually 6 plus minus 6 square root of 5 over 6, so which is going to be 1 plus minus square root of 5. So these are my 3x intercept. Okay, so that is a complete problem to find the x-intercept of and basically a polynomial function. Okay, so in the next video I will basically try to sketch a complete polynomial function. So okay, see you in the